Okay, in this webcast, we are going to work on assignment 16, bond prices. So the deal in this case is that the yield to maturity, the interest rate for two bonds, is the same, 5%. There's one which is roughly a 5-year bond, pays a 4% coupon. The second is roughly a 10-year bond, also pays a 4-year coupon. The first matures 2019, the second 2024. Both have a face value of 100. We want to think about how the prices of the bonds will change as interest rates change, as the yield to maturity changes. Okay, so I've already typed in some stuff. I've got an interest rate, coupon. Let's put the interest rate is currently 5%, all right? And I formatted this for 2 zeros. The coupon is 4%, okay? Remember to format that. You just go to Home and you do that. This is there. Okay, so what are the cash flows? Well, first of all, what's today? Well, today is the 8th of October. When's the first cash flow? Well, since the thing matures on November 15th, it pays every November 15th, and it pays every May 15th, because Treasury bonds pay twice a year. So I'm going to copy this down, and we'll go all the way to, whoops, we're going the wrong direction here. 5/15/2015. Okay. All right, now we can drop this down, and we'll go to the end date, which is that. Clear that other stuff out. Okay. So now, what are the cash flows? Well, cash flows are equal to the face value times the coupon rate divided by 2. And we're going to format that as $1, so $2. And that's going to be true until the bond matures. When it matures, we'll make that 102. So 100 times, let's say, 1 plus that last thing. Oh, and I put it in the wrong place. So let's drag. Well, let's just do this again. We will get rid of that. Okay, and go down here, and oh, what the heck, make this easier, 100 plus. All right, and that didn't work because I forgot to name these things. So we'll try once again. Okay, the interest rate and the coupon. We'll go to Name Manager. We'll create from selection. We'll hit OK. All right, let's try again. So instead of 100 times C4, this is going to be 100 times the coupon rate divided by 2. Copy that down. Down here, we'll add 100 to it. Okay, those are the cash flows. What's the time? Well, how many days between our first coupon payment and the present? We'll make the present an absolute reference. Put an F4 there, and divide that by 365. That's how many days divided by 365. How many years? Okay, and I'm not sure exactly why this is doing this. I'm going to save this document, and it gives me the right answer there. Okay, discounted cash flow. Well, to discount it, find out how much you'd have to put in the bank to get this $2 in 0.10 of a year. We take this value, and then we divide it by 1 plus the interest rate raised to the power of the amount of time. So there we go, $1.98. We're going to express that as a dollar figure. Okay. So if we drag this down, take it down there. If I save it once again, it should work. Okay. I don't know why it's not giving me equals. How much is the bond worth? Well, let's just put in the net present value of the bond. Well, actually, just the present value of the future payments. Okay. And I'm going to take the sum of all those discounted cash flow payments. That's how much I would have to put in the bank today in order to be able to buy this bond. Okay, $97.38. How do I do this for the next one? Well, the other bond is going to look a lot like this. Copy, except that we'll have more dates. All right, so let's see how we want to modify this. We can drag this down all the way to 2024. We can drag this down all the way to 2024, and we're going to add 100 in here. Okay, and we notice that this stuff isn't working here, so this is G16 minus B6. Actually, that should work, so I'll hit save again. And we're being a little sloppy here because if we look at this formula, we notice that we're referring to the starting date here. So to be a slightly less sloppy, let me go back, hit escape, go up here, and make this $sign. Copy that down. Okay, so, and hit save again because it's not okay. Oh, G7, I did the wrong thing. Oh, no wonder. G6. Okay, we'll go back up here, make this G6, and get this guy correct. Gotta be careful. Copy this down. Hit save. All right. Okay, so now how much is this bond worth? Well, we'll do net present value. It's really the present value, but if we had a negative cash flow, we'd call it net present value. So sum, and we're summing up present values. That's basically what we're doing. Okay, so this bond is worth less, $94.15. Okay, so now next question is, we want to answer, how will the price of the two bonds change as the yield to maturity changes? Well, to do that, let's create a table. So our table is going to start out with the interest rate. The interest rate is going to vary from 2%. We can make it 2.5%, whatever. Let's vary it all the way to, what does it say, 8%. Okay, so drag this down, copy, drag down, get to 8%. Okay, we want to track two things. We want to track this guy, the 5-year bond, and we're going to track the 10-year bond. So we want to see how these values change, the values of the 5-year and of the 10-year. We'll go 5-year, or we can say 11, 15, yeah, 5-year, whatever, and 10-year. All right, to find this, we select the entire table. We go to Data, What If Analysis, Data Table. What's the row cell? Well, the row cell, there is none. The column cell, that is the interest rates. So we'll change the interest rate, and we'll do that, and we'll hit OK. Let's see what happens. So hit Control S. Thing saves. And now we can do a graph. We can show how the, oh, let's do all these things in dollar signs. Home, $sign. Okay, so here's a graph that's going to show us what's going on. We could insert, scatter chart. We can draw lines there. Okay, and then we can title this how price of bonds change as the yield to maturity changes. Okay, now this isn't so good. I want to name this series. So if I go in here, let's see, the orange one is the 10-year bond. So I can go click on, move this away, click on that, and try it again. So I want to change the name there. The first argument is this, 10-year, hit enter. Okay, and click on the other series and change the name. The first argument is the name. Click on 5-year, enter. And of course I could go here and modify this. It would probably be a good idea to change the format and get rid of the number of decimal points. Make it 0. And also have it start, say, at 60 and go to 120. Looks like that's the boundaries. So we'll go up here, change this 60 to 120, hit enter. And there we go. Okay, we can also change the interest rate thing here. Format that axis, and the interest rates will go up to 8%, start at 2%, and our number is going to have no decimal points. Looks like that. It looks better maybe long and thin like that. And there we go. It looks like the 10-year bond is much more responsive to what happens when interest rates change than the 5-year bond. That's our answer. Thank you for watching.